Okay, section 9.4 is factoring trinomials, and you can see that in the last section we factored trinomials where the leading coefficient was 1, and now in this section we're going to deal when the leading coefficient has a number other than 1. Let me get my pen back here. Okay, so when I have a coefficient in front, not just a plain old x squared plus bx plus c, but this time with a value before the x squared, we have to factor it just a little bit differently. So let's look at an example. So factoring with a leading coefficient other than 1. The first step, and I'm going to just go through these steps and then we'll write them all down. The first step is to multiply the a value times the c value, the first number times the last. So 7 times 3 is 21. Now we're going to look for factors of 21 that add up to the 22 in the middle, just like we did before. So 1 times 21 are the factors that when we add them, we will get the middle number, or 22. So I'm going to use these two numbers over here to do something called split the middle. In the last section, we could take those two numbers and write them just as factors. If I do that here, don't write this part down because it's wrong. If I do this part here, then when I FOILed it, I would get x squared plus 22x plus 21. And you can see that this is not the same as what I have here. In my original problem, the 21 was split up from the front and the back, and here it's all at the end. So I can't just write these two numbers as my factors, but rather I'm going to use them to split the middle term. So I'm going to split that middle term up into two parts, 21x and 1x. You can see that these two together still add up to 22x. So I haven't changed the polynomial, I've just changed the way it looks. Now I'm going to factor by grouping like we did a couple sections ago. So the first group, the 7x squared plus 21x, I'm going to pull out a 7x, leaving behind x plus 3, bring down my plus sign. The only common factor between x and 3 is a 1, so I'm going to pull out a 1. Now you can see I do have my like terms here, and I can use my regrouping to do my final factoring. So to factor this polynomial with a leading coefficient, I end up with these two factors. Now I can always check this by doing my FOIL. So 7x times x is 7x squared, outside, inside, and last. And when I combine my terms, you can see that I end up with the polynomial that I started with. Okay, so let's take a look at the steps that we're going to write down. So to factor a quadratic in the form ax squared plus bx plus c, we're going to first multiply a times c, your first and last number, find factors of that new number that add up to the middle, use the factors to split the middle term, and then use grouping to factor the GCF from each group and regroup to two factors. The last step, again, is that step that's a little bit confusing from our grouping, but I think that once we do a few, you'll be okay. Okay, so let's try another one. This one has a little bigger number, so I would encourage you to get your calculators out. So factoring, multiplying a times c, and I'm going to do that off to the side. 8 times a negative 15 will give me negative 120. So when I factor negative 120, I'm going to have 1 plus and 1 minus, so the difference should add up to 2. So again, I can start my list with 1 times 120. The difference of those is 119. That's way too big. 2 times 60, the difference of those is 58. 3 times 40, the difference of those is 37. You can see that it's going to take me a while to get down to a small enough difference. I'm going to jump ahead because I can see that the factors of 10 times 12 will work nicely. To get a positive 2, I'm going to use negative 10 and positive 12. So again, negative 10 times 12 multiplies to 120. Negative 10 plus 12 adds up to 2, which is my middle. So I'm going to use those two numbers, negative 10 and 12, to split the middle. 8x squared plus 12x minus 10x minus 15. All I've done is take that positive 2 and change it to a plus 12 minus 10. These two terms still equal 2x. Now I'm going to do my grouping. Pull out a 4x. If I factor a 4x out of 8x squared, I've got a 2x behind. If I pull a 4x out of 12x, I have a 3. I'm going to bring down my minus sign and pull out a 5. And again, 2x plus 3. My like term works, so 4x minus 5 times 2x plus 3. And those are the factors of my 8x squared plus 2x minus 15. Again, to check that, I'm going to multiply them back together and see if I end up where I started. So foiling 8x squared plus 12x minus 10x minus 15. First, outside, inside, last. Grouping my middle two terms, I am in fact back to where I started. So my factoring looks good. Okay, so it's a little bit of a new process, but we're going to do some practice on some of them. There's a few other things we want to look at. Sometimes when I start with really big numbers, I can factor out a GCF and make it simpler. So when I look at these three terms, I think I can factor out a common factor of 3. So that leaves me x squared plus 8x plus 15. Now if you'll note, the trinomial does not have a leading coefficient. So I don't have to use my split the middle. All I have to do is find factors of 15 that add up to 8. So I'm going to write x plus 3, x plus 5, and I'm done. So again, factoring out a GCF if possible will make your secondary factoring simpler. Okay, another thing we're going to do is go back to our prime polynomials. Let's talk about that. So if I have a polynomial like 2x squared plus 36x plus 6. To factor that, I'm going to multiply my 2 times my 6 to get my 12. And then I'm going to look for factors of 12 that add up to 36. Well, I hope you can tell right away that there are no factors of 12 that will add up to 36. So this factor, I should have put a 35 in there. Let me show you why in a minute. So this does not factor. Now, if I had had my 36 in there, this would factor by pulling out a 2. X squared plus 18x plus 3. But again, there are no factors of 3 that add up to 18, so I cannot factor it any further. This, however, is not prime because I can pull out a common factor of 2. This one is prime. So a prime polynomial is a polynomial that cannot be factored at all. Okay, so let's now go back to our solve. Remember, when we solve an equation, especially one that is a quadratic, that has an x squared term and an x, we're going to move everything to one side and set it equal to 0. So I'm going to subtract the 4 and add the 3x. Now I'm going to combine my like terms, and now I'm ready to factor. There is no common factor, so I can't pull anything out to make my numbers smaller. So 8 times negative 9 gives me negative 72. I'm looking for factors of negative 72 that add up to negative 6. So I'm going to try, 2 times 36, And remember, it's a negative, so I'm looking for a difference of 6. 3 times 24, the difference there is 21. 4 times 18, the difference there is 14. 5 does not go in. 6 times 12, the difference there is 6. Perfect. So I'm going to use negative 12 because I want a negative 6. 6 plus negative 12 is negative 6. 6 times negative 12 is negative 72. So I found my two numbers. Remember, I'm going to use those two numbers to split the middle. I'm going to split the middle term up. 8x squared plus 6x minus 12x minus 9 equals 0. Do my grouping. 2x comes out. I get 4x plus 3. A negative 3 comes out. I get 4x plus 3. So 2x minus 3 times 4x plus 3 equals 0. Now that's my factors, but this time I need to solve for 0. So remember, the method is to take each factor separately and set them equal to 0. Add 3 and divide by 2. I'm going to do it in one step because I'm running out of room. Well, let me move it over here. So 2x minus 3 equals 0. And 4x plus 3 equals 0. Add 3 to both sides, divide by 2. Subtract 3 and divide by 4. And those are my two solutions. So that's it.